Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 030. The purpose of this video is to take a look at section 6, dealing with conversions with weight and mass. So I want to reference once again to the Module 3 conversion sheet that you should be using for this course. We're going to be using weight for standard measurements US, which is 16 ounces equals a pound and 2,000 pounds is a ton. And then we'll also use the metric units for weight, which is going to be this first row. So I'm going to label that weight. So the base unit is grams, and so if we go smaller than grams, we have decigrams, which is DG, centigrams, CG, and then milligrams, MG. And then going above grams, we have decagrams, DAG, hectograms, HG, and kilograms, KG. And so this goes, once again, from the heaviest to the lightest, right on down the line in terms of units. Okay, so I want to go through some examples once again that are similar to your homework to get you started. So the first one is converting 2 pounds to ounces. So we can once again use a unit fraction to do this. So we write down the quantity that we're given. Our unit fraction is going to go there, and that's going to be based off of the conversion we have, and then we want our answer to be in ounces. So we want to make sure we get our unit straight. So the conversion that we want to use is 16 ounces equals 1 pound, and I want pounds to cancel. So I'm going to put pounds in the bottom, ounces in the top in the numerator. So pounds cancels, and we're left with ounces. And then so I multiply those two fractions. 2 times 16 is 32 over 1, or 32 ounces. So the system for doing these conversions is really the same. Unit fractions, we're just using a different set of conversions. Alright, 1 ton to ounces. This one's a little trickier because notice that we do not have a direct conversion from tons to ounces. But I can go from tons to pounds and then pounds to ounces. So this is a multi-step conversion. So we want to make sure that we get all of our unit fractions correct. So let's first go to pounds. So we know that there are 2,000 pounds in a ton. So I'm going to put ton on the bottom, 2,000 pounds on top. So the tons will cancel, and I'm left with pounds. And then I want to continue to keep going and go from pounds to ounces. So we want to go from 2,000 pounds to ounces. I know that there is 16 ounces in 1 pound. I'm going to put pounds in the bottom here so that pounds cancels, and my unit that I'm left with is ounces. So get the unit straight first, and that's one of the great things about doing a unit fractions. You can do all these conversions in one fell swoop, but you got to make sure that you write these unit fractions in the right way so that the units work out correctly. So then finish the problem by multiplying the fraction. So essentially we're doing 2,000 times 16 right here to get 32,000 ounces. All right. Number 3 is similar to what we did with length, where we want an exact answer, so we don't want any decimals. So converting 89 ounces into pounds and ounces that are remaining. So we'll once again start with our unit conversion. So 89 ounces. There are 16 ounces in a pound. I'm going to put the ounces on the bottom here so that I'm left with pounds. So I get 89 over 16 pounds. Okay, and of course if I divide that, I'm going to get a decimal, which I don't want. So like we did last time, with the length, we're going to do this with long division. See how many times 16 will go into 89. So that goes 5 times evenly. So then we know that there are 5 pounds. And then 16 times 5 is 80. And then my remainder is going to be how many ounces are left over. So we can make 5 full pounds with 89 ounces, and then there would be 9 ounces left over. So that allows us to get a accurate measurement of weight using 2 different units instead of using a decimal. All right. Multiplying. So if I have 2 pounds 5 ounces times 5, essentially that's 2 pounds 5 ounces plus 2 pounds 5 ounces. Do that 5 times. So the easiest thing to do here is just multiply both of these by 5. So 2 times 5 is going to be 10 pounds, and 10 pounds. And then 5 times 5 is going to be 25 ounces. But we want to, once again, make sure that we convert 16 ounces over to another pound if we can. So obviously this is more than 16. So I can make another pound here with 16 of those ounces, and then there would be 9 ounces left over once I did that. And so this is the answer that you want to use. So that we did problems similar to that in the length section as well. All right, division. One of the easiest thing to do with division would be to essentially convert all of this to pounds and then divide, and then you can convert it back if you need to. So we know that there are 2,000 pounds in a ton, so 2,000 times 6 is going to give us 12,000. So there are 12,000 pounds in a ton, right? Plus the 1,500 that's there. So 6 tons, 1,500 pounds is equivalent to 13,500 pounds. Okay, so I converted tons to pounds and then added the 1,500 in. So then you could divide this by 5, and it's a little bit easier because then you just have one number. So we get 2,700 pounds. If we divide that by 5, and then I can convert it back, I know that 2,000 pounds is a ton. So then 2,000 of these pounds make a ton, and I'd have 700 pounds left over. So 1 ton, 700 pounds. That seems to be the easier way to work these problems. All right. Here's an interesting problem. So subtraction with the weight measurements. 45 pounds 26 or 45 pounds 6 ounces minus 26 pounds 10 ounces. So notice that I can subtract 26 from 45, but I can't subtract 10 from 6 without getting a negative. So this is kind of like a borrowing problem. What we do is we essentially borrow a pound from the 45, and that becomes 44. And then we give those 16 ounces, because there's 16 ounces in a pound, over to the ounces. So 16 plus the 6 that's already there is 22 ounces. So 45 pounds and 6 ounces is the exact same thing as 44 pounds and 22 ounces. So I just literally took a pound and brung it over to the ounces, so I added 16 here. And so in doing so, that makes the problem easier because now I can not only subtract the pounds, 44 minus 26 is 18, but I can also subtract the ounces. 22 minus 10 is going to give me 12. And so that's the best way to approach those problems. Okay. conversion with metric, right? So just like before, metric system is really nice and easy. You're just literally moving a decimal around. So notice I'm on this first row with grams. Okay, so for the first problem, we've got 4.9 grams to kilograms. So I find grams. To go to kilograms, I'm going to move to the left 1, 2, 3 places. 1, 2, 3. So then I'm going to move the decimal 3 places to the left. So here's the decimal in 4.9. So I'll move it the same number of places in the same direction. So 1, 2, 3. And then notice we don't have any numbers there, so to fill in those positions we use zeros. So 4.9 grams is going to be equal to 0.0049 kilograms. Alright, same thing for number 8. 25 grams to grams, basically going the other direction. So here's kilograms. That's where we're starting at. We're going to grams, so we're going to be moving to the right 1, 2, 3 positions. So I'll go the other direction. So I find the decimal in 25, which is here, and then I go to the right 3 places, 1, 2, 3, and put zeros in between the waves, and so we get 25,000 grams. So converting with the metric system, once again, is really, really nice. You're just moving a decimal. Everything's base 10. So use the conversion sheet. That's really, really helpful. MyMathLab sometimes makes this harder than it seems. It'll ask you to multiply by 10, 100, 1,000, or 10,000, which is basically the exact same thing as just moving that decimal around. So that's what I'd recommend doing. Okay, so number 9 here, we're doing subtraction. Our final answer needs to be in grams. So notice this is in grams, this is in milligrams. So I want to convert milligrams to grams. So look at my conversion sheet once again. Milligrams is here to grams. So I go to the left 1, 2, 3 positions. So here is the decimal in 418. Move it to the left 3 times. So 418 milligrams is equal to 0.418 grams. And now that they're both in grams, it's easy for me to then just subtract the 2. So I get 5.712 grams. This problem is similar. We want our answer to be in milligrams. So this is in milligrams, this is not. So then we want to convert grams to milligrams. So basically go the other direction. So here's grams, here's milligrams. So I want to go to the right 3 times. 1, 2, 3. Okay, so move the decimal to the right 3 times. 1, 2, 3. Put zeros in between the waves. So, sorry. 2.1 grams is equivalent to 2,100 milligrams. And then we can add those two together to get 2,253 milligrams. Okay, so you notice that these problems are very, very similar in the way that you approach them to section 5. You're really just using a different set of conversions. So once you get the process down for using the unit fractions and then moving along that metric scale, you pretty much have it down pat. So, but if you have any questions, like always, email me, come to office hours. Have a great day.